extension. We'll first try to understand what are the different type of networking connectivity Cisco SD-WAN solution has. Okay, so essentially we see that there are three type of connectivity that you will see in Cisco SD-WAN. One is that a single edge device is there, maybe budget constraint or whatever reason you have, it could be that you have multiple connectivity, multiple interfaces. One is connecting to internet, another is connecting to MPLS, right? So that's single edge connectivity with single VH device available. The second is dual edge. There are two edges available, right? So two VH devices or two CH devices or CSR or whatever SD-WAN platform you have, two platforms are available and you have connectivity, each having their own connectivity, right? Or sometimes what happens is they have dual connectivity. They both are connected to internet also, they are both connected to MPLS also. So that is another scenario. There is another scenario here is in which you have only one SD-WAN device and one traditional router in your company. The traditional router is connecting you to the MPLS, and then you have this device, which is basically your Cisco SD-WAN device. So these are the different scenarios possible, right? Now, how you will do routing, how will you point out different routes and what, basically it's a magic of routing that you have to do. So TLOC extension is when you have minimum two devices, two VHs. That's where the TLOC extension comes into. And this, you don't need TLOC extension because you have a single device. Here also not possible because they are not both Cisco devices. This could be Juniper, this could be Palo Alto, this could be anything actually, right? So it is not a SD-WAN platform device. It is something else. So the TLOC extension is only possible in this particular scenario. Now let's go back to dual edge with TLOC extension. Let me go back to one more scenario. Okay, so this is a single device, right? So single VH device, you have both connections are there, and you are using one for the tunnels, one for the internet connectivity, and you can use both for the tunnels
So,
also.
so you're sharing something right now. This on screen we can see only TLOC transport locator. That's all.
Oh, okay. So that's the thing.
Yeah.
Yeah, I was sharing these screens. Sorry for that.
Okay.
Right. So I think I have to repeat it from beginning. So
Yes, sir.
yeah. So this was a scenario. This is generally a scenario where you have a single edge device which has two connectivity, two different interfaces, but the device is single. The other scenario that we have is dual edge, where you have two SD-WAN devices. One has MPLS, another has internet connectivity, and the network can utilize both. For going through VPN tunnel, you can use MPLS. As a backup, you can use internet also for the MPLS tunnels and all that, VPN tunnels and all that. Then you have third scenario where you have, which is very common, very, very common, where you have a traditional network, which is your Cisco router or Juniper router or some other device, right? Your traditional device, which is not SD-WAN device. So this device is not SD-WAN device. Okay. And this is SD-WAN device. So still a lot of companies, you will find this because they are not completely replacing their traditional network. So there's no need for that also, right? Let's say you want to have, you already have some Juniper router or maybe Cisco high-end routers, the service provider series routers, right? CSR and ISR and all those things. And for those are basically optimized for MPLS. Your Cisco SD-WAN devices may not be optimized for MPLS. So you would not like to spend a lot of money on SD-WAN for that purpose, right? You would like to use those MPLS routers for MPLS connectivity and your SD-WAN device for SD-WAN connectivity. SD-WAN, what are the benefits? Right, depending on what do we want to achieve, it has cloud SLAs, it has all kind of internet connectivity ease, the policies that you can apply to multiple sites is using a single template, the central control policies or whatever policies, you create one working template, right? And then you apply that working template to hundreds of devices. That's the beauty of SD-WAN, right? So these are the basically scenarios possible. In this, there are a lot of routing variations possible, right? It's a game of routing. How would you route? So in this scenario, how would you route the network that they can use MPLS and they can use internet and they can use SD-WAN device for internet and they can use MPLS, or maybe they can use both for the tunnels and all that. So today, the topic that we are going to do is basically going to deal in these kind of situations, and at the end of it, we'll do a lab of Cisco SD-WAN TLOC extension, which requires minimum two Cisco SD-WAN devices. It will not work if you have one device. It will not work if you have one device of Cisco SD-WAN and another is basically some other vendor, or maybe not from the Cisco Viptela series or Cisco SD-WAN series. Then it will not work. The TLOC extension requires both to be Cisco SD-WAN platforms. So now we'll go back to our topics. There are a lot of small items also we are going to discuss today. So let's say the TLOC theory, TLOC colors, TLOC groups, restrict option, career option. Then you will look at TLOC extension theory. And then we will also see what is that. We'll also do a lab. So TLOC is, generally what happens is a complicated topic for people to understand, right? Because the way we look at WAN interface generally was like, traditionally we only care about our side, but TLOC cares about the other side as well, because TLOC is generally you form a pair with the other sides and all that. So that's the reason when we go further and more into detail, you will actually realize it that there are a lot of aspects to TLOC that makes it really amazing, right? And that it gives you a lot of control over things which were not possible in the traditional WAN. So what is a TLOC? TLOC is a simple combination of your system IP, not the physical IP on the interface. That's a very powerful thing, right? What if you have a, in WAN, what we used to have is a physical interface on the WAN, right? A WAN interface. So that means this particular gigabit 00, that's a WAN interface that is taking me to NAT, that is taking me to internet. So we are basically wired to think like that from traditional networking perspective. But here it changes the game, right? With the system IP concept, which is an amazing thing, which we have also done if you've done IPsec tunnel using loopback addresses, right? Why do we used to have IPsec tunnel over loopback? If you have two WAN interfaces, right? Let me draw it here. What was the situation where we used to have IPsec tunnel over loopbacks? Let's say if you have two devices and you have two WAN interfaces, both side two WAN interfaces. So you would like to have a IPsec tunnel using loopback address. Why would you have loopback address? So that when a physical interface goes down, your tunnel should not break down. It can go through any of the available interface at that time, right? That was the sole purpose of having IPsec tunnel with the loopback addresses, not with the physical addresses or not with the WAN interface IPs. So here they have taken it at the same level. The system IP that they have basically built it, the whole structure of the concept is that its system IP is traditionally will work as a loopback address. So the TLOCs to TLOC neighborship is always system IP to system IP, right? That's one very powerful thing. The other thing is your WAN connectivity, that you can have multiple type of WAN connectivities. So they have given it the colors. They have given it private colors and public colors. But again, the question comes, why? What is the concept of that and why they are useful? And is it just for the namesake that they are there? Basically, when we go a little further into these topics today, we'll understand why it was created and all that. And then you have two type of tunnel, IPsec tunnel and GRE tunnel, right? Which is, by default is supported in the Cisco SD-WAN platform, because a lot of places you want to support routing and all that. Those are not traditional Cisco devices. They may or may not support IPsec, and you still need routing with them. So you can have a GRE tunnel with them. So these three items put together will make a TLOC. A TLOC is a combination of these three items: system IP, the color, and the encapsulation. Three items combined is one TLOC. Okay, so here is a TLOC. And you can see that there are the VH1 and site 10, and VH2 is site 20, and this is a TLOC, right? The color they have given is green. Its encapsulation is IPsec, and system IP is 1111. Okay, so the tunnel, as we discussed, that IPsec tunnels are based on what? System IP, not the physical IP. Okay, what are the default things? By default, WAN edge routers try to form overlay tunnel to every TLOC over each available WAN transport, including TLOCs that belong to other colors if there is a IP reachability between two transport networks, right? So what does it say? It basically says that, let's say you have internet and MPLS two colors on this side, and internet and MPLS on other side, or maybe biz internet or some other name that you have given on other side. It will try to form an IPsec tunnel on both the colors, right? The point here is, will an internet connected device will be able to form a tunnel with the MPLS on the other side, right? That depends. If that MPLS site, right, does not have a public IP, because MPLS is generally what? Private interfaces, right? The private IPs. MPLS comes in both the flavors. MPLS comes as a private connectivity. MPLS also comes as a private and public connectivity, which means same circuit provides you internet and same circuit provides you MPLS, right? So when you go to ISP, the ISP will ask you, what do you need? Do you need only that you want to connect your branch offices, or you also want on the same WAN interface branch office connectivity using MPLS and internet also on the same thing? So by default, the behavior is it will try to form tunnel with everybody. Only exception is WAN edge devices do not form overlay tunnel to other devices in the same site. So if I have another vEdge router in the same site, site 10, I will not form a TLOC with him. So same site, we will not form any kind of TLOC with them. Okay, so you see that there are two different colors that we have, right? They are forming the tunnels, and right now by default, they are all forming the tunnels. So this guy is connected to two sites, this guy is connected to two sites, and everybody has two TLOCs, right? I have this device has two TLOCs, and every internet circuit itself has two TLOC pairs also, right? So one TLOC pair to T4, one TLOC pair to T3. Similarly, this guy has two TLOC pair, right? To this and this. So by default, the behavior says that you will try to form a tunnel with everybody, which is not a required feature, right? But by default, it allows you to communicate like that. Further, we will see features which will restrict whatever we want to restrict. We can restrict based on colors and all that. So TLOC color is a logical abstraction used to identify specific WAN transport that connects to a WAN edge device. The color is statically defined keyword that distinguishes a particular WAN transport as either public or private and is globally significant across the Cisco SD-WAN fabric. Okay, so here is another scenario. And let's go back to the previous one. What was it? Yeah, so you have three connectivities here. You have a 4G LTE connectivity, internet, and MPLS. And you can see that everybody has three TLOC pairs to each other. This is how you configure the color, and it's mandatory to define a color. Otherwise, it will take by default the default color, right? So it's important to define it. There are two types of predefined colors, public and private colors. So now from here, we will start understanding what is the significance of these. So these are divided into two main categories, public and private. The public colors are designed to distinguish connections to public, such as internet, which typically the attachment interface has RFC 19 address that is later translated to a public routable address via NAT. On the other side, private colors are for use on connections to cloud where NAT is not utilized. Right? The private to private connectivity, connecting two branch offices using MPLS is a perfect example. No public IP is required, right? The ISPs will provide you private IPs, and you can still connect. If you are in India and US and any other two countries in the world, you want to have MPLS circuit, you will see that they will give you private addresses and all that. On WAN edge routers, each TLOC is associated with a private public color address pair. The TLOC color dictates whether the private or public will be used when attempting to form a data tunnel to a remote TLOC. So this is the last line is very powerful. The TLOC color dictates whether the private or public address will be used. The color will dictate, is it the private IP will be used or the public IP will be used? Every site, right? Most of the sites, let's say if you have internet connectivity, of course, you have a private address and you have a NAT translated address, a public address. So when I form a tunnel to MPLS, which IP should I use? Practically, I should be using private address, right? When I form a TLOC to the other side. So these are the default colors, 22 colors. These are predefined. We have used some of these. Okay, during the authentication process with vBond orchestrator, WAN edge device learns whether they sit behind a NAT device and NAT address support. This is done using the STRN protocol. If the TLOC color at both ends is a public one, if the TLOC color at both ends is a public one, the WAN edge device attempts to form a data tunnel using their public address. So if if the TLOC color at both sides is public, what were the public? There were two type of colors, right? Public colors and private colors. Let's go back to the previous slide. These are public colors and these are private colors. So if it is, what he's saying is, if these are, it finds out that these are public color, it will use public IP to connect to the other side. It is going to use their public IP. If the colors are public, the internet IP, the public IP will be used for connectivity. If the colors are public, what if the colors are private, like MPLS? Okay, what if one side the color is public and the other side is color is private? If one of the site color is public, the WAN edge device also attempt to form data tunnel using public IP address. So even if one side is public, the other side is MPLS, you see that here, right? It will still try to initiate a tunnel using the public IP. You've seen those switches, right? When they're trunking, .1 queue and the auto trunking and all that. Right? Similar concept. The LACP concept, right? Ether channel concept. The auto and on and all that, right? So similar concept. If you have one side public, it will try to form the tunnel using the public. What if both the sides are private colors? In that case, it is going to use private IP to private IP. However, if the TLOC color both end is private one, the WAN edge device attempts to form a data tunnel using private IP addresses. Right? So the tunnel formed using private IP address. TLOC carrier. So what is this feature? This feature gives you a little more control over situations. So however, the specific scenarios might occur using the public IP address between private color is a desired behavior, right? You want to make sure that you use public IP address between private colors. By default, what will happen? If two devices are connected using MPLS cloud, right, using NAT, what will happen? It will still try to initiate the tunnel using the private address. But you want tunnels to form using public addresses, right? So if the both side the colors are MPLS, what happens? Default behavior will take over, and it says the default behavior says that the tunnel that will form will use private IP address, not the public IP address, even if that NAT, the MPLS circuit also has internet and netting. In that case, to change that behavior, there is a setting called carrier. If the carrier setting is same as a local and remote TLOC, the WAN edge device attempt to form a tunnel using the private address. If the TLOC carrier is different, the WAN edge device attempts to form tunnel using the private IP address. So here is, you see that these are two different carriers. In this case, by default, the tunnel that will form using public address, public IP. Right? The tunnel that will form using the public IP, not private IP. Overt tunnels are built between the NATed IP addresses, right? So NATed IP address, right? So by default, what was the behavior? The behavior is if these colors are both MPLS, there is no way the default behavior will take care of the thing, and there is no way that they can form a tunnel using the NATed IP. They will form tunnel using the private IP address. But you wanted to change the behavior. So the carrier feature comes into the play. TLOC color restrict feature, right? By default, WAN edge routers try to form overlay tunnel to every received TLOC from a different site using every available color. What happens? You have internet, one side biz internet, the other side is MPLS. Two sites are there. What will happen? Let me design this also. Let's draw this also. So you have this side and you have another side. This side connectivity, and they are both connecting to internet, right? But this side connectivity is MPLS and this side connectivity is internet, right? And you do not want the internet side to form to the tunnel to MPLS, right? Doesn't make any sense. Or let's say you have two internet connections and two MPLS. So this is MPLS. So what is the desired behavior you want? You want MPLS to form tunnel to MPLS and internet to form IPsec tunnel to internet. How will that happen? All you have to do is you have to choose restrict option, which means restrict yourself to your color, right? That will make sure that only the green will form tunnel to green and the orange will form tunnel to orange. If you have the restrict option applied. So you say MPLS color restrict, that means I will only form tunnels now to other devices, my remote TLOCs, if they have the color as MPLS. Right? Very useful feature in WAN circuits because you do not want your private IPs to keep on trying to initiate a tunnel to public IP, knowing that you can't reach to the internet because you have just private address. Right? So you want to restrict the feature, you want to restrict it that it should only form tunnel to its own color, which is also a granular control that you have over other sites, right? How do you design? What kind of VPN do you want? Do you want MPLS site to initiate a tunnel to internet? No, you want MPLS to MPLS. You want internet to internet, right? So you see that the green was to green. Sorry, let's go back. Now you see that after applying the restrict feature, right? The green is talking to green and the orange is talking to orange. Okay, there is another option to do the same thing. Another option to achieve the same goal of restricting data plane connectivity between the same color is using the tunnel groups, right? So restrict was a very easy, beautiful option that you just press in the template when you are creating a device template for a device. You just press there is an option there just below the TLOC. There is an option restrict. Yes, turn it on or off. So you turn on the restrict and restrict takes care. But here you get a little bit more control, right? That you can create a tunnel group, and using the tunnel group, you can basically have same desired outcome, maybe a little more additional features also, right? Because it gives you a little more control over things. So using the group also, we are achieving almost similar thing, right? Restrict is done. What's that? Okay, restrict is done. This was the thing. TLOC color versus tunnel group. So by default, in Cisco SD-WAN, BH devices will try to build a full mesh overlay by establishing tunnels to other TLOCs regardless of their color, right? What is the by default behavior? By default behavior is everybody will try to form an IPsec tunnel to everybody. But is that a desired behavior in a practical network? No. You want maybe Delhi sites, you have the head office site that wants to connect to few sites, or maybe the branch offices don't need to talk to each other, right? Let's say imagine you have a situation of HDFC Bank. HDFC Bank has let's say 1,000 branches all over India, and those branches they only need to talk to the server, the head office, because that's the place where all the data of the user is there, maybe in the data center or maybe in the head office or maybe in the servers. But branch office to branch office communication is of no use. But if they buy tomorrow's Cisco SD-WAN equipment, what will happen by default? All their sites will try to form IPsec tunnel to each other. But that's not a desired behavior, right? So that's a default behavior, but not the desired behavior. So what you can do is you can choose how you want to use the tunnel group, and you can form tunnel between the sites which are part of a group. If 3 sites are part of one group, you will have a communication with them. So here it is. This site doesn't matter what are the colors you are using. You see that this is using MPLS, Metro Ethernet, and maybe something else. You want these 3 sites, no matter what is their connectivity, what is their TLOC colors, right? You want these people to talk to each other. These 2 sites with 3 TLOCs. So what you do is you put them under one group, tunnel group 1. Now what will happen is a new site comes in, VH3, VH4, VH5, they will not talk to them till the time that site is part of the tunnel group 1. So you group them, that these are the people who need to talk to each other. You group them. Let's say I'll talk about Cisco, right? So Cisco is there in almost all the big countries of the world, right? In 2004-5, I went to China to give an exam for Cisco CCI security lab exam in China. China had such a huge presence of Cisco, multiple offices of Cisco. Now, do you think Chinese offices need to talk to India offices in whatever way? No, they need to talk to head office. So once we design a SD-WAN solution, maybe Chinese sites, they all need to Cisco offices in China, maybe Beijing and Shanghai and Guangzhou and other places. They need to maybe have a connectivity to each other, but they don't need connectivity to Cisco India offices, right? But by default, if they have Cisco SD-WAN solution, what is the default behavior? Default behavior, they will still be able to form tunnels with us. But what if you put these guys into this tunnel group? Now see that how powerful is this feature, right? You are also using the same functionality we were achieving by going to the control plane policies, right? Centralized control plane policies and creating complex policies, and then achieving this feature that I want only 3 sites to talk to each other, right? But here, without going to complexity of that, you can actually create that I want only these. So just create a tunnel group and apply to each device template without creating a centralized policy. You just create a tunnel group and just go to the device template and insert it there. Simple. One line of feature and things are done, right? So quite powerful feature. So this is what it is. There are 2 groups. You see that here, the group 1 and group 2. So group 2 is able to form to the tunnels to group 2, and tunnel 1 is these people are able to talk to. And you see that some of the devices are participating in both. One connection is participating in tunnel 1 and MPLS is participating in another tunnel, right? Because the feature is per TLOC basis, per WAN interface basis. If you have 2 WAN interfaces like VH1 and VH2 have, one will be part of one tunnel group and the other is going to be part of another tunnel group. right? So you can create full mesh, partial mesh, hub and spoke, whatever mesh you want to create, you can create that. All right, the next feature. Last resort circuit. The Cisco SD-WAN device portfolio includes WAN edge routers that support WAN connection over 3G and 4G and LTE. This is a great option in remote areas where internet circuits are expensive and not available, right? So what you can do is you can also have your internet connectivity connected to using 3G and 4G. All you have to do is that tell that this connection should be this particular connection, whatever 3G, 4G connected, should be the last option available, should trigger at the end, the last option. First option should be something else. The second option should be something else, right? Whatever you have defined there. And wherever you say last resort circuit, that means this is going to be a backup circuit. This is not my primary circuit. It's going to be my backup circuit. When the primary circuit goes down, only then this connection, the circuit should work. Now we come to another feature of, so these were all like redundancy features that we are talking today, except that we have not covered VRRP, which is also one of the additional features for redundancy. So TLOC extension is a feature that allows the WAN edge routers to communicate over WAN transport connected to adjacent WAN edge router through a TLOC extension interface. So you see that in a single site, you have VH1, VH2, maybe site 10, let's call it single site, and one site is connected to MPLS, the other is connected to internet. What you want is that in case one of the circuit goes down, your traffic should be able to go through the other one. There are two types of TLOC extensions, L2 and L3. So L2 TLOC extension describes extension between VH routers that are layer 2 adjacents are situated in the same broadcast domain or the same subnet. Okay. What we are going to use is L2. L2 extensions describe, the same thing. The SD-WAN routers can also be connected to layer 3 via any sort of IP routing. L3 TLOC extension described extension between two VH routers that are separated by layer 3 device and are situated in different subnets. Not only different subnets, I have seen designs where they are in different sites altogether. Okay, they are geographically, they are in different sites. Maybe site 10 has two offices in US. Okay, one in New York, another is in probably Boston, and they have two different VHs in both same site. Sites are both same, site 10, site 10. In that case, you want to flip, that I should use their MPLS connection and all those things. Those are possible. Most practical scenario is within the same office, you have two devices, and that's how we want to work on it. What are the TLOC extension can be configured using physical interfaces such as gigabit, ETH0, and also layer 3 sub interfaces. So you can use gigabit or layer 3 sub interfaces. There are certain things when we do practical, you will realize it. Why we are saying that? Because you require dedicated interface for this failover. So TLOC extension, you want to call it failover also. It's a good way of actually defining it, that you can just, because failover is a term that we are aware of really well, right? In all the firewalls, Cisco ASA, Cisco FTD, Palo Alto, all these devices, we are aware of how the failover works. So here also similar thing. At this point, it's a good time to discuss the notable limitations. As you already might know, TLOC are only supported on routing interfaces. Well, the same applies to TLOC extensions. They are only supported on layer 3 routed interfaces. Switch ports and SVI cannot be configured. Okay. LTE cannot be used for TLOC extension. L3 TLOC extension is not supported on Viptela and is only supported on iOS XE. The feature would not work on transport ports. Those are bound to the loopback tunnels. So these are some of the limitations that we will see. SD-WAN routers can be connected to layer 3 via any sort of routing. So that's what we have discussed already. Okay, so routing considerations. A TLOC extension interface is always configured in VPN 0 and has an IP address assigned. The WAN interface to which it is bound is specified. So here is an example of TLOC extension. There are two TLOC extensions that I see here. One is that this is a TLOC extension, and the other is this is the TLOC extension. So let's take the green side, this side, right? That this is a gigabit internet connected to gigabit 00 connecting you to internet. You want to have a backup interface of this so that if this interface ever goes down, right, you should be able to use this interface going to this side and going to through this particular circuit to the outside world. Or maybe you want MPLS people also to pass through this, so you can have that. Similarly, on this side, you want to have a backup circuit here so that you can also this is the main circuit. This interface is a TLOC extension and connecting to your WAN interface. And in case this guy goes down, you can use this circuit, or if this circuit goes down, you can use this circuit. So both two-way connectivity. That is not basically a requirement. You can also have one-way connectivity also. So let's forget about the second one. Let's leave this one. Okay. Let's leave the gigabit 05. Let's focus on gigabit 04. So what happens in gigabit 04 is that this is my primary circuit, correct? And this is the backup interface available to me. This is my, now if we talk about T22 or this particular site, let me pick up this thing. So we'll talk about this side. Now, how many WAN circuits do you see here? We see two WAN circuits. One is this, the other is now this. Right? One is the MPLS circuit going up here. The second one that we don't see is this, because he has given you connectivity of TLOC extension through this interface. So what does it look like? If we look at in the true sense, it looks like this. This side, which was only looking like MPLS at that time, now also has internet, because this circuit of internet is also available through this TLOC extension. Right? The other powerful thing about is this will also have a public IP. Okay. And this guy already has a public IP. This is also a public IP. Similarly, if you want these guys to go to internet, you need to have a public IP on these interfaces. A dedicated interface is required on per TLOC basis. So this is one. This is one. And you can have sub-interfaces, layer 3 sub-interfaces. If you do not have that many number of physical interfaces, that's okay. Right? So practically, what does it look like? It looks like if you take this circuit, right? One circuit is this and the second circuit is this. Just imagine it like this, right? So simply it is now two circuits. Although physically, how many circuits do I have? How many connectivity do I have? Well, I have only one, but one is taking me through this guy because he is providing me a TLOC extension. TLOC of whose extension? This interface is the main interface and he is an extension of him. This is the internet connectivity, right? And I am providing my extended extension to where? To my this interface. And he's providing extension to whom? This interface. So this interface needs to be connected exactly as you are a WAN interface. Also, they both are VPN 0, this and this guy. All four interfaces, the TLOC extension feature can be only configured using in the VPN 0. You cannot use any private VPN. You have to use VPN 0 because TLOC extension is a failover of WAN interface. TLOC extension is a feature of failover of WAN interface. What if you want to do it on the LAN interface? That will be VRRP. Right? VRRP is a feature which will go on. I'm just using a mouse, not using a writing pad or anything. So the writing is coming like that. So if you want to achieve the same stuff that we want to, this should go, we can also have on the LAN side. If we want to have on the private side, we can have VRRP. On the WAN side, we have TLOC extension feature. Feature configuration is easy. Routing will become a little complicated and the NATing. Okay, so we'll configure our setup now. Let's see if we have any other slide also. So here it is. Right? You see that as simple as this. This is the configuration required. This is your main interface. This is your TLOC extension. All you have to do is this, nothing else. All you have to do is this. And this side, you are putting a route pointing toward this guy. We are putting one extra route here pointing toward this guy. That's all. Show OMP TLOCs and show BFD session is a verification command. So let's go to this, our topology. Today I have to configure the second MPLS internet router that I have not configured yet. This was never used, right? You see that this was never used. So today with TLOC extension, we are going to use this device because we have always used the internet router, right? Because we have not used, till date, we have not used VH12. I think we have to configure it and we have to bring it to this thing also. So I'll see that if this device is configured. Right, so let's see that. Okay, this device is 0 configured, no configuration whatsoever. So we have to configure it as a TLOC extension. Let's see that. Let's give it a name first. Host name. Organization. Twelve dot 12.12.12. Site ID is same that we have there. What is it? Site ID was 11. So site ID is 11. Okay. vBond. vBond address we have to see. I will bring VH11 32779. Okay, so what is our vBond IP? 172.16.1.101. So 172.16.1.101. Okay, and organization system site vBond, that's all. Save it. This is our VH11 in the same site, and I'm just bringing this new device VH12. Okay, why the host name is not coming? Host name is not coming. That's okay. VPN 0, interface gigabit 00, IP address. Let's say 112.12.1.5. Okay, I forgot to do the tunnel interface has to be up also. Interface gigabit 00, tunnel interface, no shut. Okay, show IP interface brief. Show local. No certificate is there, right? So we need to bring root.pam here on this device also. And before we do that, we need to go to the ISP router. I'll see what is the ISP router connectivity. 327.32772. So this is MPLS side router. Let's say MPLS, because we have not configured second site as of now. Show IP interface brief. And let's see what is the interface that we have connected to VH12. Gigabit 0 is connected to E13. E13 is E13 IP address on 2.12.12.254. So this side is configured. Now we'll see E12, E10. I need to see the main lab router. What is the interface given there so that E12 172.16.11.254. Okay. E10 IP address 172.16.11.253, I will say. Shut. So that takes me to the lab router. Now I'll run OSPF router, OSPF 100 network. 172.16.0.0 area 0. What happened?
160.
Yeah. It's a comma. Show IP interface brief, right? So neighborship has come up, so that's a good sign. Now let's ping 112.12.12.1. That's our net. Okay, so that now the VH12 has a connectivity to our main router, right? This is what we were looking for. Now we go to the new device and we have to bring it up using all that same process of bringing the certificate and all those things, right? We have to bring the root PEM and all those things. We have to do that. We shall. I need to copy this certificate. So how do I do that? I'll go to my YouTube video and I'll copy those commands. Network goes home, SD-WAN installation. Okay, so let's see show control connections. Show control connections. Our vManage IP is 172.16.1.100, right? So I have to copy the certificate from there. So I'll type in the notepad his IP 172.16.1.100. Okay. Cannot connect to this. Network is unreachable. Okay. I don't have a default route, right? I forgot to give a default route. IP route 112.12.12.254. Right, now we go to vshell again and we try to do this. What has happened? Something wrong? Let's try pinging 172.16.1.100. He is not replying. Okay, ping 172.16.1.100. He has a connectivity. That means something wrong with our ISP side. So show IP route. Do I have 172.16.1.100? I have the connectivity. This guy also has connectivity. VH12. Show IP route. Show interface. Interface is up and up. Ping 112.12.12.254. Okay, he is replying back to this guy. Ping 172.16.1.100. Okay, show IP route. Okay, so I have not sent this route, right? That's a mistake. My OSPF is not complete because I forgot to send this route to them. They are not replying to me because we don't have the new route 112.12.12.0.55255. Right now it's fine. So now let's go back to again this guy. We shall copy. He should reply yes. Okay, the file is copied. So what's the next thing? We'll go to, we have to install this certificate. Right, so exit and install this certificate. Certificate is installed. Now request ph cloud activate chassis, and then we have to go to, we have not even opened, right? What was it? 8443, correct? So we need to get the serial number and chassis number from the vManage for a new device. Okay, now we go to certificates. And let's say this is a certificate which is not used. So we'll bring this one, right? We'll just copy any of these and we go back to our setup. chassis number, paste. Then we'll go back to this again and serial number. Right, chassis number and token. If everything is fine, it should come back to the certificate should be assigned, which generally takes 3-4 minutes. Let's refresh it. Okay, so the device is onboarded, right? VH12 is onboarded. This is the serial number assigned. Token is converted to a serial number. So that's a desired outcome. Now we go back to configure TLOC extension. But before that, I want to see what other interfaces do I have. Here, so I'll go to Sky. Okay. So this is the site that we are talking about, right? This is site 11. I have just configured VH12 connecting to MPLS for second connectivity, and the first primary connectivity VH11 already has using internet. There is a circuit between them, gigabit 01, gigabit 01, right? So this is what we are going to configure as TLOC extension, right? So this is going to be the TLOC extension. First, I will configure this as an MPLS circuit because I have not given the color MPLS here. Okay, so I have to give this color as MPLS. So let's go and do that. Show run. I just want to see what's the system name. VH12. Okay, and we wanted to change the color, right? That's the thing we wanted to do. So by default, what is the color it has picked up? By default, the color should be default or show control, local properties. Default, right? That's the color it has picked up as default color. I want to convert it to MPLS. So VPN 0, interface gigabit 00, right? Tunnel, color, MPLS. So the color is changed. Now I need to configure TLOC extension, right? So for that, I will pick up which interface? VPN 0, interface gigabit 0, 1. And I will choose any subnet that I like to choose. So something like this, /24, right? I'll just call it TLOC extension interface of gigabit 0, 0, of course, yes. And the no shut interface has to be no shut, and that's all. Right? So what I did is that I told him that you will be the TLOC extension of this interface. What is the primary interface connecting to MPLS? Gigabit 0, 0. So I'm saying you will be the backup connection for, or you will be the gateway for the TLOC extension for the other party to pass through it, right? So I'm extending that. I'm extending gigabit 0, 0 to gigabit 0, 1. Now let me take you to the drawing again, to the topology. What I'm saying is I just configured this and I configured this gigabit 0, 1 also, right? I configured this interface, right? And after that, I configured this interface as TLOC extension. TLOC extension of whom? It asked me, whose extension you want to become? I said, I want to become extension of gigabit 0, 0. So he says, that's okay, right? Now, if you look at it, I need to configure this interface as what? MPLS extension, right? This interface is what? Internet, predefined, already ready, right? But I'm not touching anything here because that's internet connectivity. I want MPLS connectivity on the same device using this extension that we have received from this guy. So VH12 is providing his one of the interface as an extension to VH11 so that VH11 has two interfaces available to him. VH11 has one more interface available because one internet he already has, one more WAN interface he will have through VH12. In case this goes down ever in the future, his users' private subnets will still be able to pass through this guy. Why? Because he has another WAN interface extension through this. Right? What is the second way to achieve that? Second way to achieve that is rather than configuring TLOC extension, why not configure VRRP here? That will do the same thing. Anyways, the purpose is these private subnets should be able to go out to the internet, right? So have a virtual IP. If this guy goes down, he can take over from there. So that is a workable solution. There is no doubt about it. Right? So this is a WAN side failover. That will be the LAN side failover. So the users will pass through this. In case this circuit goes down, they will pass through this. So I have configured this and I have configured this. Now I need to configure what? This interface, gigabit 0, 0 on VH11. So let's do that. Here I have as of now only one interface in the WAN, right? Show run VPN 0. I have only one interface, right? Which is, I don't know what is the color it is using. I think it's not using MPLS. So show control local properties. It is using default color, right? So that's fine. It can be any color. If I want to convert it to biz internet, that is also fine to me. Just for the sake of this, because we can do that. Let's do that. VPN. Okay, so VPN 0, and I will go to this, and I will say color is biz internet. So the primary circuit is color is biz internet. Okay. Now I'll go and configure VPN 0 interface gigabit 0, 0, 1, right? IP address 199.112, because the other side is 1 I have configured. Okay, tunnel interface, color, allow protocol. First I'll say no shut, and I'll say allow service all, netconf. I think I forgot to go to gigabit 0, 1 and VPN 0 interface gigabit. What is going on? VPN 0 interface gigabit 0, 1. Tunnel interface encapsulation IPsec. No shut. This gigabit, yeah, say no shut here also. I'll save it. Okay, so let's say show run VPN 0. I have two interfaces now. First is biz internet. The second is MPLS. Color is MPLS, right? So this is how you configure your TLOC extension. So if we look at the diagram, what we have done is I had two sites, VH11 and VH12, right? Here I have MPLS, here I have internet. I configured one WAN interface here, right? This was the MPLS circuit, original MPLS, and I configured this as with one single command configuration, right? Was TLOC extension interface. So his own interface was become an extension of his MPLS circuit to the other side. This guy, I have configured him as MPLS so that he can pass through this circuit and can go to this guy. It is very important to know that this MPLS and this MPLS color should be matching. If you do not have matching color, the TLOC extension will not work because this interface is an extension of this interface, right? So this interface is actually an extension of this interface, right? So essentially what we are achieving is we are achieving something like this, that it looks like one router has two interfaces. The whole purpose of this exercise is that rather than two physical devices, it looks like it's a one single device to the topology. Okay. Now the point is, can we go to the internet now, right? Using the TLOC extension, if we disable the primary circuit, can we go through the secondary circuit to the internet or not, right? So there are certain logical things that we have to achieve before we do that. The first thing is this subnet, right? Nobody on the internet knows this guy. Nobody knows this guy. Who is this 199.112, etc. So we have to make sure that there is a NATing always enabled so that these people can go out to the world, right? So let's say, so the NATing is on this side, right? The NATing is on this side. If we want to extend from that other side, the other side should have NATing, right? So other sides right now doesn't have NATing. So can I go to the outside world using this? Ping maybe 172.16.1.100. Source interface is 199.112, right? VPN is 0. I'm on VH11. Okay, I can go out using this. Now let's see if this guy can go out to the outside world using this interface. So ping 172.16.1.100, right? Source 199.111, VPN 0. He will not be able to go out, right? Why is the other side is able to go out? Because he has a NATing going on, right? And that interface is getting NATed to the main interface. But this side, there is no NATing going on, right? The MPLS side, there is no NATing going on. So he's not able to go out. Let's see, show BFD sessions. I have the tunnel is up, but only from the MPLS circuit from this guy, right? Only from this circuit. But there should be another tunnel also from the other guy also. Because VH11, 12 has two interfaces, right? Or is it VH11? Who should have two WAN interfaces in this case? VH11 should have two interfaces, right? Because VH12 is extending his interface to the other side. So VH11 should have two interfaces. So show VFD sessions. But he has only one session as of now, right? The other tunnel is not there. Show control connections also. Only one side connections are there. What about his second WAN interface? Right? What happened to his second WAN interface? So let's go back to this, right? Let's try to understand. So you see that this was a WAN interface. I'm extending this thing. So practically he should be able to go out, but this interface is not able to go out, right? These two interfaces, there should be connectivity using these. There should be two TLOCs, but this guy doesn't have two TLOCs. It doesn't look like two TLOCs. Active TLOCs are there. Maybe this is a TLOC right now, but it's not active. So what is the issue? The issue is this WAN router, right? He does not know what is this 199 subnet. This WAN router, right? The internet router, he doesn't know, because he knows this internet connectivity, right? Because that is directly connected subnet. But what is that 199 thing? This side doesn't know what is 199 thing, right? VH 12, this side, he doesn't know what is 199. So because of that, what do we do? There are a couple of things that we can do. One is that we can, if this is a public IP, I can put a static route on this, that it should basically go through this. In that case, this router, ISP router, will be aware of this public IP, if it is a public IP. If it is not a public IP, still you want to go to internet, the second thing is NAT it. Right? You NAT. Because you are NATing here, right? Because you are NATing it here, and you are extending this interface to this, he will be NATed too. Because what did you say at this time, when you were configuring TLOC extension? You said, it asked you, whose extension are you? We said gigabit 00. So whatever property is applied on gigabit 00, including the color, we have to adopt all that. So that's the reason our color at this router also was MPLS, because we are extending through him. Right? So what do? We go to this guy and we configure our NATing. VH 12. VPN 0 interface, VPN 0. .0.0 NAT. Okay, the netting is on. Show BFT sessions. See that? This is this interface, okay. Show control connections. So this is fine. Let's go to this guy. Show control connections. BFT sessions. The second interface 199 is still not there, okay. Now what I'll do is I'm going to, the other thing, right? Main thing that we forgot is default route, right? There is no default route pointing toward the TLOC extension. So how the traffic will go through that? So VPN 0, IP route 0000 199.111.1, right? Is it? What was his side IP? 111. Okay. So now this guy should be able to go through him also. You see that the new tunnel has come up, right? So another TLOC is also active and up. So it looks like now there are two different connections this router has, VH11, although physically he has only one WAN connectivity directly connected, but it looks like he has two WAN connectivities. One is through this, the other is through this. Right? So this is the primary internet circuit and this is the secondary. Both the TLOCs are up, the IPsec tunnels are up. Everything is up, up, up. If you go to any other site, you will see that these are the number of tunnels because we have tunnel to every site. VH11 has two tunnels to 11, two tunnels to 13, two to 15, two to other side also. Right? Two to the site 10 also. Except our own site, we have tunnel with everybody. VH11, which had only one physical connectivity, the second is passing through the TLOC extension. Right? So this was the original IP, the WAN IP, and this is the TLOC extension IP. If you do show run VPN 0, I should have two interfaces that I've configured. The one is passing through this, my biz internet, and the second is my WAN circuit passing through TLOC extension MPLS1. I have two routes, two default routes pointing toward both the TLOCs. and I have IPsec tunnel to all the sites. Guys, any doubt, any question? So that's the TLOC extension lab. The role of netting is very important in this. And just to show you again, the configuration is not that difficult. If you look at it, the only new thing that we had was, right, where is that TLOC extension word gone? I don't know where it is. Right, it was there. So this is the only configuration that we have. Let's go and see that here. It's not even showing that word. I don't know what is the problem with it. Show TLOC. See. This should be show OMP TLOC. TLOCs. So this guy should have one TLOC, right? Because on this side, he has. So if we say show BFT sessions, right? He's essentially extending for the other side. I'm extending my gigabit for the other side. So other side will have two internet connections here. So that's all for the TLOC extension, guys. Any doubt, any question that we have, please go ahead and ask now. Tomorrow we are going to do service chaining, which is again a little complicated topic to understand, adding a firewall or any other device, etc. And then we have security and cloud option left for the next week. So that's all for today, guys. Any question, any doubt before I say goodbye, and we'll see you in the next class then? Okay, so no questions, then see you guys tomorrow. Take care.